engineer who loves building things with Vue. Hi, I'm Sandra Rogers. I'm a developer experience engineer who loves building things with Vue, and I'm excited to be teaching this course on Pinia Fundamentals. In this course, we'll be diving into how to use Pinia, Vue's official state management library. We'll learn what Pinia is, how to set it up, and we'll build a simple to-do list application so we can practice using it. But first, let's get a clear mental model for how Pinia works. To start, what is Pinia for? Pinia is used to help with managing state. What do I mean by state? In an application, some things you see on the screen don't change, but other things have to change based on certain situations. For example, if a user is not logged in, we might show them a button that says Log In. But if they are already logged in, we might hide that button. The rendered button all depends on the state of a user being logged in or not. Now that we have an idea of what state is, the question becomes, how do we manage state across a Vue app full of components? Technically, we could store local state on each component within a data property or reactive ref. But what do we do when one component needs to communicate something about its state to a component in a completely different part of the component tree? Your components will need to share state and communicate state changes to and from each other. Theoretically, we could emit events upwards and then use props to pass that state back down. But I'm sure you can see how this can quickly get messy, hard to maintain, and even harder to debug. So instead, wouldn't it be convenient if there were a global state, some single source of truth for the state of things across your application? And what if this global state was accessible to every component in your app, regardless of how deeply nested they might be? And wouldn't it be better if that state were reactive? So when state changes occur, anywhere in your app that is relying on that state will automatically update? Well, I've got good news. This is exactly what Pinia provides for us. Now we'll look at an example store so we can begin to have a clear mental model for how Pinia works. A store is the structural pattern of state management that Pinia provides. Let's compare it to the structure of a Vue component. Keep in mind that a Vue component is dealing with local state and the Pinia store is managing global state, but the structure we set up in each is similar. We can build our mental model around that structure. A Vue component stores local data in its data property if we're using the Options API, and in a ref if we're using the Script Setup API. And the Pinia store keeps its data in the state property. A Vue component has methods that can update the component's data, i.e. local state. Pinia has actions which can update the state in our store. And finally, while a component can use computed properties to return a processed version of data without affecting the original data itself, Pinia has getters, which can use the Pinia state to return a processed version of that state. Now that we're getting a clearer sense for how Pinia works, let's look at a simple example to see it all in motion. Here's a store from a to-do list app. This store tracks the state of the to-dos, and it includes an action to add them to the to-dos array and a getter for returning to-dos which are done. Using this demo to-do store as an example, how might this look in motion? As you can see from the component we call the add to-do action, which adds the to-do into our state. And if we want to get only the to-dos that are done, we could use our done to-dos getter to retrieve them. Hopefully with that you're getting a clear idea of how Pinia works. Another reason it's so great is that it's modular by design. With Pinia, you can have multiple stores separated by logical concern and directly import a store into the components that need them. This helps with lazy loading because the bundler can now code split by associating the different modules with the different pages in which they're being used. This also gives Pinia great TypeScript inference. Now that we're clear on how Pinia works and we've seen a demo of it in action, we're ready to dive into the core concepts and start building a to-do list application throughout the rest of this course. Since this to-do list app will have two sibling components that need to update based on state changes, It makes a good use case for incorporating the Pinia library, even though it's a simple example. Let's take a look at what we'll be building. Our application will be made up of a form with an input, where the user can enter items to add to the to-do list. And it will present those items in a list with a checkbox and an X, so the user can mark them complete or delete them from the list. The form and the list are the two sibling components I referred to. They both need access to the same global state, and Pinia will help to provide that. We'll learn how to define a store that will hold the state data for the to-do list, containing all the items that have been added and whether each item has been completed or not completed. And we'll write actions to add items to the list, toggle the items complete or not complete, and even delete the items. Along the way, I'll give you some extra information that will be useful to you as you're learning to use Pinia in your own projects. Now let's start building the to-do list application and learn the fundamentals of Pinia. See you in the next lesson. In this lesson, we're going to create our project for our to-do app, and we'll create our first Pinia store. Let's get started. We'll use the create Vue CLI to scaffold our new Vue project. We'll type the command npm init vue at3 and name the project to-do app. We'll select which plugins and presets to include in the project, including Pinia. This way, we'll start our project with the Pinia plugin already installed, and we'll have an example store and some boilerplate to work with. Now let's cd into the project folder. Opening up the project in VS Code, we can confirm that Pinia is a dependency in our package.json. Inside main.js, we can see that the app is already importing create Pinia and telling our app to use it. Notice we have this stores folder with a demo counter store. This provides us with some boilerplate we could use to help us create a store. Now we'll just delete out some of this boilerplate code, including these icons and components. Then we'll create the three components that will make up our to-do list app. To-do app, the parent component, and its child components, to-do form and to-do list. If we align these three component files next to each other, we can quickly scaffold them out. Note here that we're using the script setup API, which is a compile-time syntactic sugar for the composition API, allowing us to write less boilerplate code. Script setup gives us access to things like variables and methods from within the template, so we don't have to return them inside of a setup method like we would with the normal composition API. Here's how these components will eventually look when rendered in the browser. We have the parent to-do app, and nested within that, we have the to-do form where we can add an item to the list. And we have the to-do list where the items are displayed. Now we can start fleshing out our to-do app component, giving it a class and heading. Also, nesting the to-do form and to-do list components inside of here, which we'll need to import above in the script section. Now heading into app.vue, we can import our to-do app component. Then delete out all this boilerplate code and nest our to-do app here. We'll also delete out all the CSS that came with the demo app. Now that our app is starting to come together, we can build out our Pinia store. So we'll delete out the demo store and create our own store called To-Do List. We'll first import the define store function from Pinia, and then export a const called use to-do list store. Inside that const, we'll define our store, giving it a name and an object of options such as state, getters, and actions. I'd like to bring your attention to this naming convention we are using in this const, use to-do list store. This naming convention makes sense because whenever we import and use this store inside a component, we'll import it as use to-do list store. Now we'll start creating a global state object and give it a to-do list array, which will eventually contain an object for each to-do item. We're making great progress. We set up our project and we created our first Pinia store. Now we're going to learn about mutating state with actions. And with that, I'll see you in the next lesson. Continuing on our journey to learn Pinia Fundamentals, now we'll learn about mutating state with actions. Heading back into our to-do list store, we can set up our first action, where we add a to-do item into our to-do list state. We'll also add an ID property to the state since we want each item to have an ID that increments each time a new item is pushed into the to-do list array. And each to-do will start out as incomplete. By the way, if the syntax looks odd to you, it's just shorthand for this, item:item, where the second item is what was passed in via the argument. While we're here, we can write an action to delete a specific item from the to-do list by filtering by the ID on the to-do object we want to remove. With all that set up, let's jump back into the to-do form component so we can build out a simple form to input new to-do items. We'll add an input element with a vModel for the to-do and a button to add a to-do item. Notice how we're using vModel to bind the to-do, which we'll add in our script section as a ref. This will ensure to-do is reactive, so it updates immediately to be the value that the user types into the input. Once our user has input their new to-do item, we'll want to submit the form and have the submit event trigger an action in the store. So we'll add submit.prevent here. We'll wire up the action to be triggered next. And since we want to be calling our Pinia add to-do action, we'll need to import use to-do list store and set up a local store const here. Now we have access to all the state and actions on our to-do store. Theoretically, when the form is submitted, we could run the add to-do action, but we want some slightly more complicated behavior here. So we'll write a new function that first checks to make sure the input field is not empty, then runs our add to-do Pinia action, sending in the new to-do item that was just created. Then we'll clear out the to-do ref. Now we can go ahead and use our add item and clear method in the form submit handler. Next up, we'll just add some simple global styles, and we can check it out in the browser. We can see that we're able to add new to-do items into the input. And as we can see in the Pinia Dev tools, our to-do list state is being updated with those new items. Our project is really coming along. We can see that the action to add to-dos to the Pinia state is working. Next up, we'll want to make sure that we can display those items on the screen. We'll need to learn about how to bring in those state properties into our to-do list component, making sure those properties stay reactive. And we'll tackle that in the next lesson. Now that we're successfully adding new to-do items to our Pinia state, we can start displaying them from inside our to-do list component. In our to-do list component, we'll need access to our to-do list state, so we'll import the use to-do list store, and we'll create a local store const to run it. Soon, we'll be looping over that to-do list to print out its items in this template. But before we do that, we need to import a Pinia helper called store to refs. We'll import store to refs and use it with the to-do list we bring in from the store. This helper method allows us to bring in properties from the store, ensuring the reactivity for each property. It does this by creating refs for each of the properties. This is similar to Vue 3's to refs, if you're familiar with that. Now with that out of the way, we can use the to-do list store data in our template, and it will stay in sync with the store. So let's go ahead and v4 over every to-do in our to-do list, giving it a unique ID key, and printing out the item itself in a span. And with that, we can double check everything is working as expected in the browser. Notice that each item that is added to the list also has a completed property set to false. We're going to write an action to toggle that property. We'll write a toggle completed action that takes the ID of the specific to-do item, checks the to-do list array for the item with that ID, and toggles it to either true or false, meaning the item is completed or not completed. Now we'll head over to the to-do list component, and we'll bring in the toggle completed action from the store. In the to-do list component, we'll add a span that will be the check mark to be clicked. We'll add an event listener to listen for a click on the check mark, which will invoke the toggle completed action in the store, passing along the ID of the specific item. To make it simple, we'll use Unicode for the checkmark symbol. To add the styles, we'll first add a dynamic class to the to-do item span in the template. Then we'll add CSS to change the look of the item as it is toggled true or false. Let's test it out in the browser. Now, when we click on the check mark, we see the line strike through the item to show it's completed. This is looking great. We have an app that displays the to-do items, and we can check them off as complete or not complete. We've learned how to use Pinia actions to make this all happen, and we know that store to refs is the key to keeping store data reactive in the template. We have just one more thing to do to finish our app. In the next lesson, we'll add the delete functionality, and we'll wrap it all up. Let's add the delete feature to our app. We already wrote an action in the store to delete an item from the to-do list. Now we'll bring in that delete to-do action into the to-do list component. We'll add another span so that we can create a delete button. This time we'll use a crossmark Unicode symbol to represent the delete button, and we'll add an event listener to listen for a click that will invoke the delete to-do action in the store using the specific ID of the item. Let's head back into each of the components so we can add some styles. We'll add our own styles to the 3 components, removing styles that came as boilerplate when we created the app. These styles will make our app look much better. Now let's see the final product. Everything works great! Congratulations! Together we have built a to-do list application using Pinia. Along the way, we've seen how Pinia can benefit us in a simple but realistic context. I hope you enjoyed this course, and I hope you have a new appreciation for how Pinia can help you manage global state in your Vue projects.